systems of equations by substitution. You can solve a system of equations using different methods. Different approaches work better in different situations. Okay? So we've done graphing, which is actually not the best way, it's the worst way, because of the fact you have to be dead on perfect with your lines, and if you're sloppy with it, you won't find the right point. Secondly, not every graph ends perfectly on an intersection, so sometimes it's like 2.5, 3.5, and that's just estimation. So graphing is really not the best way of doing it. Now we're going to do, there's also substitution, which we're doing right now, and elimination, which we're going to do later. Elimination, I can spell.
That's wrong.
Okay? So we're going to fill in some blanks here. You're going to solve one of the equations for x or y. It doesn't matter. Pick the easier equation. Okay? So you want to pick the one that's going to be the least trouble. So if you already have an x by itself or a y by it, with no number in front of it, that's the one you're going to choose. Substitute the equivalent expression into the other equation. Okay, so whatever you did, you're going to send that into the other one. Solve the new equation that should just have one variable in it. Because if you substitute in, you'll have x and x, and combine them. Use the variable you just found for one variable to help you solve for the other. So once you find x, plug it in and find y. Okay? And then check your solution is written as an ordered pair. So, let's see it in live action. Your first step is to solve for a variable by itself. Well, our first step's already done. We have y equal to this by itself already. We don't have to do anything. Now, could you solve this one for x or y? Yeah, you can move something over. But why do it when this one's already done for you? Try to find the easiest. Be like water. Water always finds the easiest route through something. Find the easiest path. Okay? Now, we're going to take this 3 plus x, which is the same thing as y. Okay, so any of you play sports, think about it. Okay? You and someone else, probably multiple people, play the same position. So during the game, coach will say, hey, 35, go in for 37, whatever. McAvoy, go in for Thomas, whatever. All right? It's substitution. We are saying that y is the same thing as 3 plus x. Okay? Or it's like if you have a nickname. Okay? So I could call you y. I could call you 3 plus x. It's the same thing. What we're going to do is take this 3 plus x and put it in for y. Now, once we do that, okay, we're going to write, so we already have this. We have y equals 3 plus x. It was already done for us. Right? When we substitute, we're going to have x plus, we're taking the y out and putting 3 plus x in, equal 5. Now, we're going to solve that one. So, x plus x is 2x plus 3 equals 5, right? Okay. What do we get rid of first? We have 2x plus 3. Good. Get rid of the 3. You're going to have to do it by subtraction. When we subtract, when we subtract 3, we're going to have 2x equals 2. Now, what's attached to the x? 2. By what property? Multiplication. How are we going to do multiplication? Division. When we divide, we're going to get x equals 1. So x equals 1 is the first solution. It's right off to the side. Now, we're going to take that 1 and plop it in for x either here or here. It makes no difference. Again, though, you want to find the easiest path. If you put it in here, you're going to have to move it over. If you put it in here, you just have to simplify. I'm going to take that route. 3 plus 1. So that means y equals 4. And now I have my x is 1, y is 4. That's my solution. Now, if you have it this way, it's kind of backwards. And we're not going to spend the time doing all these. But we've already done this before. Test this point. So look. 2 times 3 is 6. Minus 2 is 4. That works. 2 times 4 is 8.
No.
Minus 17 is not 2. So this one doesn't work. And it's already done for you. You already know which one's right. But that is how you would do it. You plug in 5, 3. You might find it works for this one, which it does, but it doesn't work for this one. And you find out that this is our winner, 3, 5. That one is on both lines. It makes both of them true. That's what a solution is. It's the intersection. It's the point that's on both lines. So think about it. You're in the car. You drive through an intersection. As you're driving through the intersection, someone T-bones you. Right there, in the middle of the intersection. Okay? That means they hit right into the side.
I know.
Okay, so when that happens, you are actually, please say, what road are you on? Well, if you're in the intersection, you are technically on both roads. Why? Because you're on this road, they are on this road, but they hit you in the intersection. You are in the middle of both streets. You are on both streets. You are the solution to both streets. That's what we're doing here. This point right here is true for this one and this one. It's the intersection. It's on both lines. Okay, this is about the easiest substitution you can get. They're already both set equal to y. So all we're going to do is substitute this in right there. Or we can substitute this in right there. It makes no difference. We're going to get 2x plus 3 equals 3x plus 2. Now, remember, when we're doing this, we have a choice. We can move the 2x over right and get positive 1x. We can move the 3x left and get negative 1x and create another step for ourselves. I'm going to subtract 2x. Cancels. We get 3 equals 1x plus 2. Subtract 2. X is going to be 1. Once I get that 1, I can plug it into either one of these, here or here. It makes no difference. 2 times 1 is 2 plus 3 is 5. 3 times 1 is 3 plus 2 is 5. So when I plug it in, I get 5. My last step is to write 1, 5. This one, again, is an easy one. It's already solved for y. I'm just going to plop that in right there. So all I do is write 3x minus 2. Now you got to be careful with this. Notice there's that 2 there. When we throw the 6x minus 7, we can't do this. Because what is that? Is that 26 now? Is it 2 times 6? No. You've got to put in parentheses. Whenever there's a coefficient, you've got to put it in parentheses. So 3x minus 2 times y. Remember, this is all y right here. Equals 5. Now I'm distributing my 2. 3x minus 12x minus 14. Remember, because I'm setting it to both, equals 5. Sorry, my bad, plus 14 because it's negative times negative. Now, 3x minus 12x is negative 9x. Plus 14 equals 5. When I subtract 14, I'm going to get negative 9x equals negative 9. And again, this is very boring. X ends up being 1. Now I have a choice. I can plug 1 in here. Not too bad. It's 3. Then I have to subtract 3 divided by negative 2. Or I can pop the 1 in right here. If I do that, it's already set up for me to be done. Y equals 6 times 1 minus 7. Well, 6 times 1 is 6, minus 7 is negative 1. So my point is 1, negative 1.
That is kind of boring.
We're going to get a different x on the next one again.
Yay! I'm excited.
Okay, this one is already solved for x this time.
Oh, man.
So this one is going to get substituted right there. Notice though, the x has a coefficient. So when I write the 2, next thing I write immediately is a parentheses. Negative 6y minus 9. Now remember, this is my x right here. So I still have to write the negative 3y. This gets left off all the time. You'll substitute in and forget the rest of the equation. Don't do that. Now, notice how I have y and y. It's going to work out. Distribute the 2 to both. Negative 12y. Minus 18. This is positive times a negative for both. Minus 3y equals negative 3. Combine like terms. Well, negative $12, you borrow $12, you borrow $3 more, you're in the hole 15. Don't lose the negative 18. To get the y by itself, I need to add 18. Cancels. Negative 15y equals 18 minus 3 is?
Negative 6. Negative 9.
18 minus 3 is 15.
Don't go here.
Divide by negative 15. This time we got y equals negative 1. At least it's not 1, it's not it. Now, I'm going to put that negative 1 somewhere. Again, take the least resistance. I'm going to put it right here because it's already solved for me almost. X equals negative 6, careful, negative 1 minus 9. Negative 6 times negative 1 is positive 6. And 6 minus 9 is negative 3. Now remember, we solved for y first. That doesn't mean we write that first. Negative 1, the y still goes over here. I see that happen a lot. People go, oh, the first one I solved. No, it's still alphabetical order. Negative 3, negative 1. Okay.
Why does it say uh-oh?
It says uh-oh because for once we actually have to do something.
Oh, dear Lord. Oh.
Notice that we don't have something solved for x or y. Now, we have 4 choices. We have 4 choices. We can solve for this y right here. If we did that, we'd have to move the x but divide by 3, which would lead to fractions. We can solve for this x. We have to add 2y and divide by 4, fractions. We can solve for that y, no fractions, but still we have to move the 4x over. This one has no coefficient except 1, which we don't write. That's the one we want to solve for. To get that by itself, we're going to subtract 3y. So we're going to get 7 minus 3y. That's what x is equal to. Now, you could write negative 3y plus 7. It makes no difference. I'm going to take this and I'm going to plop it in right there. 4 parentheses. 7 minus 3y. Don't forget this. Minus 2y equals 0. I'm going to distribute the 4. 28 minus 12y minus 2y equals 0. Combine like terms. 28 minus 14y equals, sorry, I got ahead of myself, 0. Now, I have two choices. I can move the 28 over and divide by negative 14. I can move the 14 over and divide by positive 40. It makes no difference. I'm going to move this over just for that. That's going to give me 28 equals 14y. When I divide by 14, I get y equals 2. And guess what x is going to end up being? Now, when I plug 2 in for y, it doesn't really matter where I plug it in. Okay? So 3 times 2 plus x equals 7. 6 plus x equals 7, and oh boy, guess what? X ends up being 1 again. So my answer is 1, 2.